Okay, looks like you're up and running, Scott. To introduce the next speakers they're from US Synthetic. We have Scott Schmidt, who's the VP of Sales and Engineering, and Brandon Linford, who's the Director of Product Development at US Synthetic. Scott, I'll let you guys go ahead and take the floor.
All right, hey, thank you. Appreciate the opportunity to be here and present to everyone. I want to leave us some time for questions, but if you have more questions, you can see our emails right here on the title slide, and we can connect you to either answer your question or connect you to the right people. All right, next slide there. Brandon's running the slides today. So just a little bit about US Synthetic. Our headquarters and all of our manufacturing are in Orem, Utah, which is about 30 minutes south of Salt Lake. It was, founded in 1978 by Lewis Pope, who's the son of Bill Pope, who worked with Tracy Hall in the early days of Mega Diamond. And Tracy, of course, was the person who invented synthetic diamond in 1954. And you can see the products that we make there. We have, we basically have the presses that make PDC cutters and diamond bearings for the oil and gas industry. And we have 250,000 square feet. And we're really proud of our team members and the way we do our work. We were recognized with the Shingo Prize a few years ago, and it really recognizes our employees and their engagement in connecting customer value to their daily work and continually improving it. And it was a great recognition for that team. We just changed our parent company just changed from Apergy to Champion X in June. It's the same company. They acquired Nalco Champion, which is a chemical division, and changed that name. So if you see that name change, it's just a name change, but our emails will change soon, we've heard. All right, next slide, Brandon. So just real quick, just if you don't know how diamond's made, you take diamond grit, you put it on a tungsten carbide substrate, you put it in a big press that goes, over 1 million PSI. It's similar to the pressure of taking the Eiffel Tower and putting it in the palm of your hand. And then you put a bunch of heat through the part and center the diamond together, and you end up with a diamond insert like you see on the right there. And again, if come see us at US Synthetic at any time, and we'll show you this process and teach you some cool stuff. All right, next slide. So this is what we're going to talk about today. I'll talk about kind of the first part of this winning strategy that we feel is really key to being successful. And the first is, it's obvious, it's about having the best technology. This is the technology industry. And we've got to continue to drive to differentiate our products and lower the cost per barrel, like we've heard on a lot of this conference already. And then you got to take that technology and apply it in the right way. And Brandon will talk about how to apply it, this idea of application-specific design, using the design space to apply it with these trade-off curves that we generate. And then Brandon also talk about the future. How do we see and we innovate even faster? How do we use the analytics to do a better job? We're always trying to be able to see the problems that we need to be solving, because capacity is a limit for all of us. And so picking the right one is very critical. Picking the wrong one is a really wasteful activity. But this design space is something we could really talk about for a week with this group, because it's something we spend a lot of time on, because it really is about seeing capacity, seeing priority, and then how do we see ahead or behind on the teams that get selected. So, and then you have to take that design space, and it's got to be integrated with the drill bit technology groups, because that is such a key integration in making a drill bit that is successful in the field. And again, we'll touch on that later. So, I mean, this is the question we get, and it's kind of the question of the title of our slide: what's the state of the union, and will PDC technology advance? And the answer is absolutely it will advance. Our history has been strong with technology advancement, and I would say the technology is accelerating, not de-accelerating. You know, when we landed on the moon, it was a giant leap for mankind, and everyone wants that giant leap in PDC, but it was really hundreds of thousands of smaller steps and great decisions made by really great people that got us to the moon. And PDC advancement is the same way. You know, we really had to reinvent the way we solve problems in 2015 with that downturn. Everyone lost a lot of capacity and a lot of great people, yet the problems didn't go away. So we had to reinvent the way we organize our teams and solve these problems. So and when I have to just acknowledge all of our engineers at US Synthetic, what a great job they've done on that. I'm really proud of the work we've done. The last 5 years, we've had 45 focus teams. These teams are focused on failure modes that we see in the field, identified by our other partners, our drill bit partners. We have new technology, base technology, R&D technology that we're continuing to work on, and then products and processes that have to be invented in order to manufacture that technology. And the goal of these teams isn't to create a product or a piece of equipment. We teach this idea of creating knowledge. Paul said it really well. There's learning and there's forgetting. And the number one waste in engineering is knowledge waste. So we have to continue to create these trade-off curves that can be used and reused and then built upon. And it's been a fun transformation for our teams over the last 5 years, even though we've had some challenging market conditions. And then you can see some results on the right there. We're continuing to expand impact strength, and both high end and some low ones. And the lows don't mean they're bad. These are trade-off curves that some of those products will work great in one area of the world and one will work great in another part of the world. Because there's another curve that is the opposite of that curve, unfortunately. That's just the world we live in with these engineered materials. Even though we do push the limits of, or I should say, we start moving off the curve, and we have moved off the curve over the past 10 years. And many PDC companies have done that as well. We're all pushing each other, which is a good thing. You can see thermal performance there. We're continuing to advance that. This abrasion chart is a fun one. We look at from 2000 to 2017. This was a standard test we did just to compare, and the latest products we can't even put on the test anymore because they don't wear anymore, so we have to reinvent it. But we see over 1,000 times improvement in abrasion resistance. So it truly is an engineering material. Diamond is not diamond. It can be improved, and we'll continue to improve it. And there's just a picture of a couple of parts, a thick diamond versus a thinner diamond part. And some of these last teams that we had ran in the last couple of years have enabled us to take the best known processes in premium diamond and put it on a thick diamond table. And we've done thick diamond tables a lot, but we've had to maybe sacrifice some performance in order to do it. And now we don't have to do that anymore. And that enables teams to not only drill more efficiently, but also they can shape. Their imaginations of shaping a diamond can start to grow, which is the next subject. We've heard shapes a lot on this conversation, and don't want to show anybody's proprietary shapes, so I've just pulled some generic shapes here that we make. There's Texas. You guys are in Texas there at Landry's. The shapes on the right, this is a generic tri shape, I guess I'd call it. And the one next to that is one that our engineering groups use as a capability test to make sure that we're just to show the capability and to use as a standard there. But diamond shapes aren't new to the industry. I've been at US Synthetic 23 years, and when I started, there were shapes all around me. Some of my biggest headaches were working on shapes as a designer and as an engineer. What has really changed, though, is the ability to shape the most premium diamond. We can shape any diamond now we want. We can apply these complex shapes, and it's still growing. We're all still learning about shapes, how they interact with with the bit. How do they enhance the bit stability, cutting efficiency, and overall reduce cost per barrel? Because that's what they have to do. Otherwise, it's not worth doing it. Our capability has, we've worked hard to have the highest capability. We want to prototype anything our partners bring to us in less than a week, and our goal is any dime in any shape, and that's where we're always trying to expand the use of those and understand failure modes that we see from shapes, because as Paul mentioned too, they want to put more load on these cutters, and we need to continue to find a way to take the load and not fail. I'll hand it off to Brandon.
Thanks, Scott. And I'm going to talk a lot about how we take these capabilities that Scott talked about and apply them to the field. We get asked very often, what is the best cutter? And this turns out to be a very complicated, it depends answer. And there's three categories that we have to consider. The first is very obvious, it's the formation. So for example, in Neza Sea Lateral in Saudi Arabia, it drills 2 to 3 feet an hour and will, bit might last 100 to 300 feet. It's very different than drilling a vertical in North Dakota, where we're drilling much, much faster through lots of different transitions. And so it definitely changes what's the best cutter for each of those applications. So the two other categories to consider, drilling conditions and bit design, aren't as obvious. And often this results in us trying to shoot for a moving target as operators and drill bit companies continue to innovate in how they approach solving problems. It changes how we need to approach solving cutters. For example, an operator might drill with one bit for the vertical, but because they innovated on their tripping speed, change that to a 2-bit vertical and actually drill it faster. But by doing so, they put a lot more weight on those bits, which changes maybe what the ideal cutter is for that application. And of course, Scott mentioned with bit design, we love our bit partners, and we believe the best solution is when the cutter company and the bit company are innovating together on a solution, because there's so many things that are interdependent there. So it becomes quite complicated for us to say, what is the best cutter? We develop hundreds of new cutters every year. A lot of those cutters get field tested and don't end up getting adopted because it didn't improve performance. And the ones that do get adopted, they get used. But there's a lot of work between us and the bit company to figure out what's the best cutter for each operator in each application. So I'm going to talk through the process we go through to try and apply some scientific rigor to how we approach this question. And the way we approach this is through an application-specific design methodology, where we use a scientific method to make sure that when we recommend a solution for an application, that is based off of observation and scientific data. And really, it starts within the field, looking at the dole. We've had the opportunity to look at all sorts of data. There's terabytes of data that's collected at the rig site. But for us, the most meaningful one is the dole. And we want to look at lots of doles. We want to look at lots of failures. We want to look at where those failures are happening, where the conditions those failures are happening, and how those failures are starting. And so we want our customer engineers spending a lot of time with our bit partners to evaluating dole conditions. Once we feel like we kind of understand the quantity and failures types that we need to go after for that application, we want to drive to root cause. And so we've developed many lab tests that replicate field failures in our lab, so that we can verify that the failure mechanism is consistent with what we've been seeing in the field. Very often we've gone through a development cycle where we guessed wrong. So we developed a new product, but we misunderstood what the root cause was. And so it wasted time. We had to go back and start over. So up front, we want to understand what is the root cause of the failure, so that then we can use the trade-off curves that Scott mentioned, and our customer engineers who are experts in cutter design can pick what are the best features to put for that cutter in that application, and understand the trade-offs. So they might understand that, hey, we're going high on abrasion, but we're sacrificing some toughness, and this is how much we're sacrificing. But based on the dole conditions, we believe that's worth it. Or, hey, I can sacrifice some abrasion or thermal for this other benefit. And of course, we validate back through field testing to validate that we solved the problem or moved it forward. So we go through this process hundreds of times a year with all our bit partners, and it's a good process to go through, but that process takes time. And so when a bit comes out of the ground and an operator needs a better solution, often they don't want to wait for us to develop a new product. And so we also believe that we need to have a set of solutions that are ready to be deployed quickly for each application. And the analogy we use here is a golf club set. If we were going golfing, we wouldn't want to bring a golf bag full of the same club. We want to have a diverse set of clubs where we know how to best use them and when to use them. And so with each of our bit partners, we work to develop a diverse set of solutions. And then our customer engineers work with their customer to look at the application. Oftentimes, after they evaluate the application, they don't recommend designing a new cutter, but using a different cutter that's already on the shelf that can help dramatically improve performance overnight. And we've seen this all around the world with lots of different operators where we're often using the wrong cutter for the wrong application because it's so hard to see through all the noise what the best cutter is. And so we like to apply this methodology to help us be better scientists at putting the right product in the right application. So the question we ask is, what's next? What do we need to do to continue to improve this model to create value for operators and bit companies? And a gap in the industry that we would like to close and would like help from others to close is dual bit analytics. So if we look, we have a team at US Synthetic that analyzes dual bits, and we probably analyze 0.5% of the drill bits in the world that are around. And bit companies analyze a lot more than that, but certainly we don't analyze every bit. And so we'd like to throw out a target of analyzing every dual bit, looking at every cutter and every bit in a way that allows us to see failures. And we believe this will do a few things for the industry. One is monitoring duals for changing failure modes. So instead of waiting for an operator to change their drilling condition or the bit design to change, and for us to learn maybe months later that we need to change the cutter design, actively monitoring duals as they come out of the ground so that we can see failures as they're happening and recommend the best product for that application. That enables us to match the PDC cutters for each bit, drilling condition, formation, as well as then feed that information to drilling bit and PDC engineers to see and solve problems faster. Make it so clear where our problems are happening and the challenges that we need to solve. And then the last thing on that is, once we do come up with a solution, being able to see if we made an improvement. I've been doing product development for PDC cutters for 15 years, done a lot of field testing. It is so difficult to know if we're making the difference because it takes so much manual work to understand if we're moving the needle forward. So this is an area where we think there's a lot of value for innovation. We have a manual process for how we do dual bit analysis reports, and we provide this information to our customer. You can see an example on the right. But one thing I want to demo for everyone today is at US Synthetic, we've invested in a new product that we're developing. We expect to be able to launch it next year in 2021. But it's an automated dual grading software that can run on your phone, and it can be used on the rig site, it can be used in a bit repair facility to use some artificial intelligence to automatically dual grade the bit. And not just the IADC current standard, but to look at every single cutter and classify the failure modes as they come out of the ground. So I'm going to try and play this video. Hopefully it works, and I'll talk through some of the things we're doing. It's still a work in progress, so it's fairly rough still. But it should give everyone an idea of kind of the technology that we think needs to be developed in the industry. So again, it runs off your phone. Every user can have their own password and credentials so that the information's only kept with that one company. And then there's some information we can enter about the information as well. When we start scanning the bit, the software is recognizing the diameter of the bit, how many blades there are, what are the primary blades, what's the first, second, third, fourth, fifth blade on this bit. And this kind of sets up the dual grading process. So it can recognize where in space everything's at. And so we just took a picture there and you can see that, and then collected some statistics on that bit. And again, this is just setting up for the dual grading process. The next step is to scan each blade. And so we're going to come down and scan the first blade, and we're going to take a picture, and the software is going to recognize how many cutters are on the blade and where they're at. You'll see this represented in blue and orange boxes. It can identify the inside cutting structure and outside cutting structure. And then we go into analyzing each cutter. In the future, this workflow will be smoother so that it can be done with less photos. Right now, we have to take a picture of each cutter. So we're going to take a picture of this cutter. The software is going to recognize what that cutter face is, what the diameter of that cutter should be, and then measure the percent wear of that cutter that's gone. At the same time, it's going to recognize what faults might be on that cutter as well, like spalling or broken, maybe chipping, or the tangential failure that Paul mentioned, and then collect this information. And so you'll see it work on this other cutter as well. This is a work in progress, so we're still working on improving the training of the AI software. But again, the value we see in this is being able to create something that is so easy to use that we could potentially analyze every bit. An operator could use this on a rig site, the bit company could use this in their repair shop. And all that's great, except if the information just goes into a black box and it's not easy to know how to use that information, then we have to develop the workflow of how we use that information to actually make decisions. So we're also working on how we take that information into standard reports that can be created, both in PDF format and others, as well as doing maybe deeper analytics after we've collected multiple bit runs to look for trends and monitor how performance is changing. So I bring this up as an example of where at Synthetic we see investment is needed. We know there's other people in the market that are developing similar type of solutions, and we're excited about that because, again, we're ultimately motivated by making the best PDC cutter for every bit application. And so we want to see solutions come out that help us see better what problems we need to solve. We believe we have the right technology, and a lot of times the challenge is just figuring out how to apply that right technology to that application. So those are the slides that Scott and I had prepared. We have a few minutes for questions, and we want to leave some time open to answer some of those questions.
So we got the first one. About I guess I don't know. You guys can ask the questions. Is that right? Because I can answer that one. Someone's asking, does USS focus on developing proprietary shapes, or do you see a bigger role as a contract manufacturer of drill bit company shapes? Yeah, up to this point, we have some generic shapes that we have developed. Our focus has been on capability, capacity, and there's so much knowledge that we don't have about bit dynamics and the software that our bit partners use, that we've mostly left it up to them. And to be honest, just trying to keep up with all their great ideas has kept us busy.
Got one here, Scott.
Scott, I was curious with the software that you had, that you were just talking about, the operating software, is that something just internal for you guys now, or you see leasing that out, or subscriptions, or how would that work as to look at the same design over and over with better games?
Did you get that, or you need me to repeat it?
I think I heard most of it. It was, is it something we have now, and are we going to offer it through a subscription? Is that correct?
Yeah. Yeah.
Okay. Yeah, Brandon, do you want to address that one?
Yeah, so we don't actually see a lot of drill bits at our shop. We just make the cutters. So we think the value of this product would be in the hands of operators and drill bit companies. So we plan to offer it as a subscription service to them. We're still fairly in the development, and again, we look forward to making it a commercial ready product in 2021.
The initial idea of it was for our customer engineers to work with internally with our bit partners, just to use as a way to streamline that process of again seeing the failure mode, so that we could make better decisions on where to put our R&D efforts.
I see a question from Paul. It says, are you categorizing the type of damage, not just percentage of damage? We're doing both. So we like to get both quantitative and qualitative data. So we're trying to we're currently getting quantitative data on the wear size and categorical data on whether the failure is present or not. So we're doing both. We both want to collect, hey, that cutter has a crack or a spall or a chip, as well as how much wear is happening on that cutter. Other questions anybody has for us on what we presented, or other topics around cutters, or what we see happening in the market?
Hey Scott, it's Dustin here. I couldn't type into the Q&A, but I'm just curious, what's big on the development list for 2021 and 2022? Where do you think U.S. Synthetics focus is going to be?
It's a great question. I mean, we're in that stage right now of evaluating, what are going to be what we call our moonshots. What are we going to really go after versus just the incremental work that we're always doing. And some of those, I can tell you some of the things on the list, what they are, and I see a lot of companies working on them as well. And one of them is what we showed today, is just how do we streamline and get better information back faster and remove all the steps, even the steps between the drilling and what our drill bit partners, the information they have, I think, because they're doing a lot of great stuff too with the same work. As far as cutters go, we're always going to be advancing, of course, thermal impact and abrasion. But beyond that, I mean, we see, we see some work that has to continually be done in things like mechanical attachment, things that really help reduce the cost of this the process, because it is getting more difficult to, we just got to be more efficient with lower oil prices. And anything associated with that is what we're gonna probably put on our moonshot. But it has to hit that sixth side of that Rubik's Cube. You can't just have the one side of the Rubik's Cube and say, I'm going to solve the technology side. You guys figure out how to get paid for it. We have to continually think about how do we not only advance technology, but make it more, more affordable.
Scott, do you see those other questions pop up?
Am I mute there? Let me pull them up here. So do you see large increases in innovation coming in the latter half of 2021 with more bit companies having increased access to leach product? That's a good question. I mean, I don't know about, there's certainly always going to be the pressure on that, and more people will have some access to it. But it still comes down to, you have to be, 5% better still dominates this market. So it's not just leaching that makes a product and a cutter great and a drill bit great. It's the combination of so many things. Certainly we're all wondering what that world's going to look like. And it's a big question. What, if any, impact? Okay, so leaching patent, same question. And Brandon, do you have any other comments on that one?
Yeah, the only comment I would make on that, Scott, is certainly having more bit companies having access to leach cutters will improve their product portfolios, what they can offer to the market. But each of those companies will have to go through a learning curve of how to best use leach cutters. Their bit designs are designed around non-leach cutters or other solutions. And so I think we still believe the winner is rate of innovation, whether it's the bit company or the PDC company, who can learn the fastest. And those folks that are going to be able to start using leach cutters aren't going to come up to the same speed as everyone else right away. They're going to have to go through their own learning curve.
Hey, this is Paul. I typed in a couple of things into the chat because I couldn't do Q&A, but one of the questions that I asked was what percentage of the cutters have some kind of a shaped front face, this chip flow kind of control thing, and then what percentage are non-cylindrical that you're making these days?
Yeah, I think in general, I think we're seeing obviously a transition to more shaping. I would say we were, less than 5% of our products were shaped on the face, Paul, and now we're seeing a transition, probably over 20 or 30% and growing. So it's a moving target right now. As far as shaped on the outside, that's still a very small number. Most cutters are still round. I think that has to do with, the ability to repair and ease of manufacturing. And again, that's where I see some advancement that we could in the future possibly with with other types of attachment, whether it's you know, I'm not, you know, mechanical or other ways that might help improve the cutting efficiency through shaping.
Yep, excellent. And kind of relating, you know, you and I have talked, and we've had a number of discussions. What about quantifying the tangential toughness? So where you either get a ranking at the very, that'd be the kind of bare minimum, or a rating that says it'll handle so many megapascals loaded in this direction or whatever. So.
Hey, Brian, I'll let you take that one.
Yeah, so we have two tests we use to quantify that. And the reason why we need two tests is we see that we have to separate out both in where the crack initiates. So we use a MTS load frame to measure how much load a cutter takes before we start to see damage on that cutter. And then once the crack occurs, then we measure how much load it takes to actually propagate and terminate the cutter. Those things tend to be opposite in each other. So if we have a cutter that can take, say, 10,000 pounds of load before it cracks, it doesn't take very much load for that cutter after it cracks to break, where we might have a cutter that only takes 5,000 pounds of load to crack, but might be able to take much, much more load before it actually terminates. And so we play with those two tests to build our trade-off curves. But this is an area, Paul, that we recognize there's room for innovation. We're only loading the cutter in one direction. We're not taking the force vectors. Certain bits and applications with different depths of cut and can change all of that. We recognize we're just probably scratching the surface on our understanding of what's possible there.
Excellent. Yeah, and this is exactly what I wanted to hear. And again, our commitment is with ExxonMobil XTO is to share everything with you guys. I know you're a supplier of a supplier kind of thing, and there can be issues. Sometimes people get really sensitive, but my view is I want the best product I can get my hands on. And so, yeah, we will definitely commit to work more directly with you guys.
Awesome.
Oh, that's great. Thank you, Paul.
I think he addressed that a little bit.
How are we doing on time? I think we're over our slot. And I know there's probably a couple more questions, but
You talking about this?
help us keep us on track.
Yeah.